Hello, so today's problem is 1534, convert binary search tree to sorted linked list. I'm using Lintcode because on Leetcode this problem is locked. So I'll try to solve here and we'll see how it can be implemented. So for the current problem we have a binary tree and we should binary search tree and we should convert it to a doubly linked list. And we also should this double link list doesn't have like head or tail. The head just connects with the tail and the tail just connects with the head. And because it's binary search tree, so the left subtree nodes are less or equal the root and the right subtree nodes are greater than root. Um, and this applies to all subtrees to the same here. 1 is less than 2 and 3 is greater than 2. Same as here. 4 right right branch 5 is greater than 4. Left branch 1 to 3 is less than 4. So idea I have right now is do uh, DFS and do DFS in an interesting way. So I want to have public, let's say private DFS, and we're gonna push the current head. So I'm gonna have three nodes. Oh, and also the requirement is that we should uh, modify it in place. So we cannot recreate the nodes. We should modify those from three nodes of a binary search tree. We should convert them to three nodes of linked list. So what I'm gonna do is basically do this three node equals current equals new three node, and let's say we have uh, three node, let's say array. I have three node and then put here new three node, let's say -1. Let's say we have current and head tail equals new three node 2. And for the DFS, we're gonna have three node current. So the current is basically the head of the list head, let's say. Or we can call it list tail also. Let's call it tail head. List head. So we're gonna put the list head here and we're gonna and I'm gonna also pass the tree node head tail head. Okay. So on every node we have this dilemma. If we have a left not populated, if node left not equal null, we do the following. We pass DFS, we do the node left, and we pass list head, and we pass tail head. So let's say for the current node, we wanna link the node to current list head, and so that the list head becomes node becomes new list head. So we're gonna have list head 0. Okay. let's say we have, I probably don't need this on list head to simplify it a little bit. So, okay, we just need empty one. Yeah, empty one. So it can be just one. So if list head 0 equals null, we just gonna push the list head 0 equals node. Else we need to do this list head dot right equals node, and then node dot left equals list head 0 dot 0, and then we should update also the current list head 0, so the current node becomes the new list head. And what's important here, we didn't modify the node right. Here we only modified node left. So I do the following: if node right not equal null. So I do the same DFS node right list head and then tail head. So for the tail head problem, we can either go through all nodes in a double linked list, and then I'm gonna be like they're gonna be like what offline operations, or every time we update or like we have a new list node, a list head kind of we assign a list head to a new variable, to a node here or like here. We do the following: if the tail head 0 equals null, we're gonna update the tail head 0 equals node. Else tail head 1 equals node. So that we're gonna fill the tail head if they're gonna be just one node. Like first one, if they're gonna be 0 nodes, tail head gonna have all nulls. Like on the 0 position and 1 position are gonna have nulls. If the current tree has like 2 nodes, like 1 node first, a second. So if it has 1 node, then only 0 elements under 0 gonna be populated. If the So in this notation, there's gonna be head. So we need to just modify it with head. So tail list tail. So be gonna always add to the list tail, and then gonna be head tail list tail, not left, list tail head tail list tail equals no. Yeah, so we always gonna in this notation end we're gonna increase the list from like to from the tail perspective. We're gonna always add like to the tail, and the head tail gonna have like 2 nodes if there are more, uh, 2 not null nodes or like elements if there are more than or equal to nodes in a tree. And if there is only 1 node in the tree, we'll only populate the head, and the tail gonna be here like null. If there are zero elements that are both head and tail gonna have null values. Yeah, that's it. And in the end, we call DFS root, and then list tail, head, tail, and then we need to check if list head tail 0 equals null. So if the root not equal null, we're gonna call the DFS. Otherwise, this will fail. This DFS will fall here, not at left. That's the first place where it will fail. Um, so we need if head tail equals null, we need to return null. Else if head tail 1 equals null. So we basically need to map uh, head tail 0 dot right equals head tail 0, and then head tail 0 dot left equals head here head tail. And then else we need to do head. So head dot, in this case, what we're gonna have head so tail dot head tail, so tail dot right equals head tail 0, and head tail, so it's head left equals head tail 1. And we basically don't need this uh, else's if, because we always remove it. We always return the value. And we need to return head tail 0. So that's it. Let's try to run the test. Let's try to submit it. Okay. What if I do this one? I can even upload the video. Interesting. Okay. Okay. So the problem is that the solution is the following. Um, so high level, we do the DFS. I do the DFS here. I pass the current list tail. I grow the list by accessing list tail element and like populating the expanding it from the tail. whatever they call here tail, but usually it's called head. Um, and I do the in-order traversal here for the DFS. So I visit first left, I update mm, the current node, use the root or like current root or current like current parent, and then I update the right. I go to the right subbranch, and every time I update list tail, if there is not null, and also I'll have this structure that will help me to like this array of two elements that will help me not to do that going through the list in the end. I'll just populate it every time I update the node, the list tail element. So that's it. And in the end, I also need to wrap up this this double linked list. So I need to wrap up the tail 5 element like with the head 1 element. So I need to recreate these links. So basically I'm doing it here. And if I have just one element, it's going to be self-reference. Self right equals self, self left equals self. Yeah, that's it. Gonna wrap up. Hope you enjoyed. This problem is on a link, as I said, is available on the Lintcode. It's open. You don't need the premium for this problem. If I try to search the same problem on Leetcode, I'm gonna have, let's say, Leetcode, let's say convert binary search tree to double linked list. You see this problem is locked. Um, yeah, that's it. Again, the last time I'm gonna show the solution. So also copy that one. Okay, hope you enjoyed.